Hello and welcome to Technical Utkranti, and today we'll be looking into how to merge case sorted arrays using heap. These are the questions that we have done in heap, and let's look at the sixth question on heap today. So here is the question. You are given three sorted arrays over here. So this is the list of list, and this list of list has three lists, and all of the elements inside each individual list are sorted. We need to merge all these lists such that we get the resultant array which is sorted via merge sort. Here we do not involve heap here, right? Heap is not. So firstly what we do is we merge these two arrays by how? Like one pointer will be here, one pointer will be here, and whichever pointer value is less, that goes into the final array and that pointer goes ahead. Again the pointer values are compared, the lesser one comes into the final array and this pointer goes forward. Again the pointer values are compared, whichever value is less, that particular value comes in the final array and that pointer goes ahead. And then once one of the pointer exceeds the array, the rest of the values of the second array totally fills up the space. Okay, and then this particular resultant array is then merged with this array and both of them are sorted. So the similar pointer wise merge sort technique is used to merge this array, these two arrays, to get the final array which looks like this. This approach was via merge sort, but now we will see how to do it via heap. So let's take an example where we have an array 1, 2, 8 and 3, 6. Let's assume we just have these two arrays, array of and stored in an array of array. And how are we going to do it? With the help of heap. So we see that these two arrays are individually sorted. All right. Okay. Now what we'll do is we'll take the help of heap. So what minimum heap does is whatever elements you store in it, at the top you'll get the smallest elements. So we'll be utilizing this particular property of heap. We'll begin with storing the first element of both the arrays into the heap. So heap would look something like 1, 3, and here we'll store the array number or array indication. Let's say this is array A and this is array B. So we'll be storing like 1 comma A, 3 comma B, alright, and 1 being the parent and this being the child. Alright. Okay, then what will happen? We will continue with the following set of instructions until Q is not empty. Okay, Q is not empty. What we'll do? We will get the topmost element of the queue. Okay, so topmost element of the queue would be a pair. The first element of the pair would be the number and the second would be the array indicator, correct? So we can say that element is E of 0 and array indicator is equals to E of 1. Alright. Now what we'll do is once we have gotten the element from the queue from this particular array, so we will be filling the queue with the next element of this array if there is an element left in the array. So what we'll do, we'll see if length of array I, right, of length of whatever array that is here, A of I, is greater than 0, then whatever the element is, AI of 0, we will Q dot put. So we'll put in Q the element of AI and we will delete the 0th element of AI. So this deletion would help us to ignore the elements that are already being considered in the queue, right? So when we had inserted the first element into the queue before this while loop, we will delete the first elements. Okay, then we will get this. What we will get here? We will get 1 from array A. So 1 from array A, right? This one we will append. So let's suppose this is the final array, and here we will append the whatever element that we have got. So here we will get 1 to begin with, right? And from array A, we see that still it has 2 elements. Its length is not 0. So we'll take the element at the 0th index. So this element would come at 0th index of array A, right? So this would be going into the queue, and queue would become like 2 comma A, right? So 2 becomes the parent now. Okay, and we'll delete this particular element. Okay, fine. Queue still has 2 elements. It is still not empty. We'll get the element. This element would be 2 comma A. So 2 will come here. Okay, and array A is still of length 1. It's still not empty. So 8 will go into the queue. So when 8 will go into the queue, queue would become like 3 comma B will be the parent, and 8 comma A will be the child. Okay. Okay. Queue is still not empty. We'll get the element which will be 3 comma B. So 3 comma B will come out of the queue. It will come here. Now from B, we'll insert the next element, which is 6. So 6 comma B will come here. Okay. Okay. Queue is still not empty. The next element we'll get is 6 comma B. And when we had inserted 8 from A, we should have deleted it. So just as a reminder. Okay. Okay. So now we'll get 6 comma B. 6 will go here. Okay. And when we had inserted 6, 6 should also have been deleted. So 1, 2, 3, 6 B. Now we have array B whose length is completely exhausted. So we will not be able to insert anything from array B into the queue. Okay. So queue would just be now of length 1. Queue is still not empty. We'll get 8 comma A. We'll insert 8, and array A is completely exhausted. So we'll not be inserting anything. In the next run, queue will be empty. So this execution will stop, and we have gotten the final array that is merged and sorted of these two arrays. So here I have taken this example of 3 arrays. Okay, and I have created one queue. This is the array of arrays or list of list. Firstly, I am saying that I will insert the 0th element of all the arrays into the minimum heap and delete those elements. Okay. So why I am deleting? I am deleting so that every time when I am accessing index 0 of a particular array, I will get a new element or the next element. Okay. Okay. This array would constitute our final array. So until we have something into the heap, we'll query the topmost element of the heap. We'll append the element, the value into the array, and array number we'll note down. Okay. So we'll access that particular array which is indicated by the array number, and see if there is something left into that array, then we will be just putting the 0th element of that array along with the array number into the heap, and we'll delete the element that we have already put into the heap. Okay. So this deletion is necessary in order to stop the algorithm. Otherwise, every time when we access the first element, it would be the same element. Okay. So this algorithm finally would run and give us the desired answer. So let's see. Yeah. So I hope you understood the algorithm and the code, and if you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.